Hello. Hi. So this is my first time presenting in a disco. Uh, so let me start. Okay, they already have my slides. So you all must be curious that a cold Monday, $1 million in the cloud bill. Yeah, it is a true fact, and I deflated the entire amount. It was near about $1.8 million. One was looking very much catchy in that tagline. So who am I? Uh, I will be telling you in a while. Okay. These things happen. Okay. So either this is not working. Ah, okay. So let's throw this away. Uh, so yeah. No, the presentation. Yeah. Okay. Yeah, this one is it. Okay. Yeah. Okay. My name is Prerit Munjal. I'm the founder and CTO of KubeCloud. I don't have any ambassadorships, but I'm LinkedIn Top Voice 2024, and I run a YouTube channel with the name Tech with Prerit, uh, where I teach people in my part time about cloud native stuff. So my key expertise is in Kubernetes, and I teach cloud native stuff on my YouTube channel on weekends. And that's the beauty of the open source thing, that without communities we are nothing. And yeah, this talk is about day 100th of operations, right? Because crypto mining attacks happen very, very, very rare. How many have you ever got a chance to experience how crypto mining attack look like? No one. Okay, this is your first time. So for today's agenda, we will be exploring what is this $1 million thing. What was the actual root cause? What was our initial approach? What were the hot patches that we applied? And then later on, like even I had a doubt in the starting how Terraform, crypto mining attack, Terraform, infrastructure provisioning has nothing to do with crypto mining attack. And later on, we will be also seeing what happened to that cloud bill, because this is the story of my previous startup. So that startup was barely even making $1 million in a year. So we were build nearly 1 million for the entire month. Okay, so let's see our initial architecture. Uh, so yeah, so this was our initial architecture. I know, a little bit childish, but there were users, and in front of users there's a gateway. Then the first step was G Suite logic. That was our custom logic. So something about business that we were outsourcing, or we were not the end user company. So we were building some products on top of Google Cloud, Amazon, the AWS part, Azure part, and then we were selling it to the end users. Okay, so we were just building something on top of all the cloud providers. So initially there was a G Suite logic that we implemented to make sure that the users were authenticated and authorized. Next, there was a G Cloud magic in which we had a lot of shell scripts, a lot of nearly about 120 shell scripts that used to run at every login attempt or at every attempt by the user. So it comprised of all the deletion scripts, all the cron jobs and all that thing. And later on, talking about our the previous architecture, we had 400 plus projects. And the question why 400 plus projects, because at that time we were facing like we built something and it was quite famous at very early time, and so does the users. And second thing was we had 25 plus services, so Google Compute Engine, Dataflow, BigQuery, Bigtable, Cloud Spanner, Cloud SQL, everything we were using in our particular architecture. And from 400 plus projects, 80% were actively running and 20% were reserved. So we already knew that there is a bottleneck. We should be running at least 70 30 or 60 40% in reserved and active running. So there was a constraint, because when you are new to Google Cloud or any cloud provider doesn't give you the projects that you want. It is totally dependent on your billing account. Okay, how much you how much are you billed in that particular month. So this was our previous architecture, and this was the cloud bill. Okay, so if you see on 11th January and 12th January, we were billed nearly 1, 2, and 4 zeros, and then 105 4 zeros. So greater than 1 million. This is the screenshot for just one billing account. We were having around 4 to 5 billing accounts, so they were billed differently. And if you see the previous days, okay, 9th January, 7th January, and 5th January, it was 990, 1100, 870, 730. So this was the impact on our billing account, and this is the bill breakdown where we saw that App Engine was causing us nearly this much amount. This is in rupees, but again, you can calculate in dollars, and we had 4 to 5 different billing accounts. And we were also getting billed in, I think, it's the similar for our 12 January and 11 January part. So this was the initial bill breakdown, and this is the monthly the breakdown of previous month, not that January month, but of December, the previous month. So we were billed $125, $148, and the growth was consistent, and we knew that this is not something that we should be worrying of. Now comes the next part, that is the bill of January 2024. So it is more than 2.2, right? And yeah, so this is how much your cloud bill will look like if you ever face any crypto mining attack. So how did it happen? Okay, so the first reason was we had a compromised service account key. By this I mean that even we don't know how did it happen. Either some of the developers exposed that key, or somebody got wrong IAM permissions, they downloaded that key. As I told you, we were just building something on top of Google Cloud products, so it may have happened that somebody downloaded that key and gave some root privileges to them, to that particular person. But still, we don't know anything about that. We got into the logs, but as the account was suspended by Google Cloud, we couldn't get the exact logs of that particular moment. Because this happens in cloud. If the Google Cloud already has their running algorithms which tell them that, okay, this crypto mining attack is happening right now, so they permanently block your account. Then you have to send your email to that particular cloud vendor and ask for you have to give proper explanations. Second thing was, even if it would have happened, we were having very poor cleaning up resources. So it used to happen before as well that some of our resources were running for around 1 month, and because it was just N1 standard one, and who cares about that, right? It costs very, very less. So we didn't take it seriously that, okay, this is just N1 standard one, let it run. And so we were very bad at shell scripts, because if you know shell scripts and you are running thousands of shell scripts on a single server, the CPU utilization, all those stuff are not valid, okay, are not good from an engineering point of view, that you are running thousands of shell scripts on a particular VM, and then the shell script is deleting those resources, and it is not also a viable form of deletion as well. Either you should be consuming cloud APIs or some other solution. And the last and very important part was, we were not having any org-wide restrictions on the resource count and type. By what I mean is, so in Google Cloud, we have around 80 plus services or 60 plus services, and each service can have multiple permutations and combinations, and the entire globe is divided into regions and zones. So just calculate the permutations and combinations. So this led to like from a human point of view, it is not even viable to go into every single option that, okay, N1 standard 1 and US central 1, N1 standard 2 with GPUs and US East 1. Okay, so it is not viable to go into each of the particular permutation and combination and then put some hard limits on it. So this was the main reason that crypto mining attack actually happened. Okay, so uh, what was our initial approach? So this was on a Saturday and Sunday night. Okay, and I was on leave because weekends are for fun, right? uh, but for DevOps and cloud engineers, it is not, especially if you are in the leadership team. So our initial approach was that we flushed all our old projects, because it would have happened that they already downloaded a particular key from a particular project, and we had 400 plus projects. We could have easily run a particular gcloud command to list down the service accounts, but again, we decided to flush all the old projects and just ask Google for 1,000 plus new projects. The next was we also deleted the previous billing accounts. So we started a new billing account because anyway, we were not going to pay $1 million to Google Cloud. The second was we built an in-house tool. Okay. So what this particular tool did was, uh, so if you know about custom roles, right, it already created custom roles on your behalf. So there was no need to go into custom roles, define your custom role, and then assign it to particular users or service accounts. It already created all those IAM custom roles if anyone in the entire wanted anytime. So this was it. And the third part was we also added some billing alert edge cases, and this I think you should all be implementing. So this is how your particular billing alerts look like. Now, the bottleneck here is if by any chance you cross the 120%, you won't be getting any further notifications from Google Cloud. So once that 120% threshold is covered, and you know that, okay, 120 is covered, then 140, 160, 170, nothing will, Google will not even ping you, or any cloud provider won't ping you that 170 or 180 has crossed. The entire agenda or the funda behind billing alerts is to send you alerts based on particular thresholds. Uh, so my advice to you would be that, okay, put on actual as well and forecast as well. Okay, so 200, 250, 300, 450, 500, put for forecast as well. So in case any of the threshold has already passed, all those future combinations you should be notified for that. And for the previous answer, we also blocked that particular entire domain. So not only one user did this, around 5 or 6 users did this. As I told you, we were building something on top of Google Cloud and other providers. So the entire domain got listed, they became our customers, and then they this particular attack. So what they did was they created compute engine with Tesla T4 or A100s, I don't even remember, and then they took the RDP access and they started the crypto mining on our particular VM. And Google was at that particular point of time was not even good with their crypto mining policies, so they were still building on that, and they didn't even block that particular project. Okay. Billing alerts is done. So I did a LinkedIn poll. Okay, that apart from the infrastructure provisioning, Terraform can be used for which purposes? So around 72% of them told that obviously infra provisioning. 14% said that they are going for security, and 14% were out of the box. As we saw, Grafana, it can be used with Grafana and something on top of panel and other stuff. And some person told that Ansible controller and private hub in AWS, creating and maintaining backup environments that can be quickly spun in case of a failure in the primary environment. Uh, so this is how much people know about Terraform, right? Because Terraform is marketed as infrastructure as code, but it is more than that. Uh, so before even going to quotas, before even going to Terraform, let me tell you something about quotas. Okay. So how many of you know about quotas? Anyone? Okay, just one person. So quotas by default, you won't, if you're if you're coming from a developer background, you won't be facing anything regarding quotas or metrics. This is more towards platform engineering and DevOps and cloud side. But from a very broad level overview, these quotas are specifically designed by cloud providers to track you and track your resources for them and for you. Okay, for your betterment, for their betterment. So for Google Cloud, we have around 21,000 metrics or quotas, you can say. Okay, so quotas, as I told you, the entire globe is divided into regions, zones, and we have multiple resources. So all those permutation and combinations, they compose of particular metric and quota. So they are particularly designed for keeping an eye on your consumption in order to prevent overconsumption and even sometimes underconsumption. Because for cloud vendors, everything is about cloud bill. They don't care anything about other than that, because uh, cloud is meant for giving you the infrastructure, and you are supposed to run your particular services. Uh, Second thing is these particular quotas and metrics are dynamic in nature. So for example, it's 40 as of now. A particular quota is 40 as of now. It can turn or it can change to 140 after 7 or 10 days. It's totally dynamic, and you have no control over it. Only the cloud vendor has control over it. So and it is directly proportional to your billing. Okay, so the more you pay, the more quotas will be raised. And also quotas are not equal to resources allocated. Okay, so I will be showing you in a demo as well, not theory. uh, and yeah, it can be applied at global and regional level. This was about quotas that you needed to know. Now, quotas can be applied for multiple use cases. Now, first one was security. In our particular point of view, we applied it for security. We also applied it for cost restrictions. So if you just want to apply some quotas on a very global level in your organization and you want to keep an eye on the bill, quotas are the thing for you. Nothing other than quotas can help you in this particular thing, because uh, it is not viable. You can't disable your billing account. If you disable it, your entire infra will go down. So quotas are the only thing. And also, if you want to go into more managed and supervised environments, so for example, you have 100 interns joining in your organization, so they will obviously create some bigger resources, and they might like forget about deleting those resources. So for that particular use case, quotas are your best friend. So this is a little bit older screenshot with 18,000 quotas. Okay, and this is a particular API. So in the entire Google Cloud, we have APIs for each services: data flow API, Cloud Run API, and for Compute Engine, we have Compute Engine API. So in this particular thing, you can see we have 12,929 quotas in just Compute Engine API. The reason is such that because entire thing in Google Cloud is built on top of Compute Engine. So if you're shooting up a Google Kubernetes engine, GC is used behind. And also if you're going to go for some LLM models, so the entire pre-processing thing is done through Compute Engine. So it has around 13,000 quotas just alone in Compute Engine. And yeah, I think, but how on earth can Terraform help in this? We saw how crypto mining attack happened. We also saw what are quotas, but how? So this is a hidden functionality. I think even HashiCorp employees don't know. Okay, so this is where you define, okay, in the provider section, you define Google beta, and in project, you define the project ID. In service, I will be showing you in a little while in a demo what service is, and then the metric, okay, and then the limit that you want to the apply, okay. So it is a very basic main.terraform file, and you just have to define the override value and enforce always enter true. That's how your quotas will transform, and the metric and limit I will be showing you in a little while. So this is how you define metric, or you define quotas using Terraform for particular services. This was just meant for compute engine, I guess. No, it was meant for default request. Next one is for N2 CPUs. And similarly, I told you we have A2, we have C2, we have C1. Similarly, we have metric for different configuration. Now, time for a demo. Let me play a video. Actually, I was told that we might have some internet issues, so I recorded it. But believe me, I trust in live demos. So, okay, let me play it from the beginning. So this is particular project with the name HashiDays Sydney. My current company, that is KubeCloud.tech, and we have HashiDays Sydney. So in the top panel, you just have to search for APIs, quotas or APIs. You can go to any one of them. Here you can see that we have 18,000. Like, these quotas keep on changing, so there's no defined quotas limit. Now we have 18,000 quotas, and here you can see from the bottom panel as well, multiple, some are set to 30, some are set to 0, some are set to different levels. That is totally totally configured by your cloud vendor based on your billing. So now we went to compute engine, and here you can see the service name is here, compute.googleapis.com. That is the service name that we passed in the main.terraform file. Now the next part is I will be showing you what it is comprised of. Okay, it also shows some beautifully drafted graphs, and in quotas and system limits, as you can see, this particular compute engine API has all the things: your ephemeral IPs, your static IPs, your networks, your persistent disk, everything that you can think of in creating that particular VM machine. Okay, so we have A2, and similarly you can see we have US East 1, we have West 1, we have Africa South 1A as well. So it is set to 0 by default, and you can't change it. You just have to raise a query to Google Cloud that we are going to run these many workloads in Africa. Can you please just add please? So can you please raise that particular number? So if your billing account is good, then they will surely raise that. So here you can see that the values can differ. They are dynamic in nature, and it also shows current usage percentage. So if you're running particular VMs in your entire org, it will show how many of them are actually running. Now, so okay, let's go a little bit faster. So this is my particular VM machine in Cloud Shell. So I've already written a main.terraform file. Let's see what's inside that. So this is a very sample file. In our particular production use case, we were having around 600 or 700 Terraform files. So there are two strategies. Either you club all those services in a single Terraform file, or you have multiple files based on different services, or you may have different files based on different projects. Totally up to you. We were following different services per different project, so entirely different case. So here I've defined the project ID, that is HashiDays Sydney. I've also defined the N2 region override. Okay, so if you can see, okay, it was very much difficult to not speak and record this particular screen recording. Okay, so here I've defined N2 region override, and the region is US Central 1. And I've passed the particular, if you see the service name, that is compute.googleapis.com that I showed previously. In metric, I will be showcasing you in a little while. So first you have to make a spreadsheet of all those metrics. That thing you can't really automate. You need to have, either you ping Google Cloud that I need list of all the APIs. Google Cloud will process it in 1 week or 2 week, and they will give you the list, or you have to go to each metric and select and copy that particular metric. Now, in the override value, you can pass anything. Okay. Now I'm going to that uh, particular metric, and I will be showcasing you what's the actual use case, actual percentage. So it is 8 by default. Okay. And this is the metric type that you have to select: compute.googleapis.com/n2 underscore CPUs. So this is how you need to make a list of all those metrics. Again, this is for day 100 operation. So I don't think most of the people ever experience crypto mining attacks on Google Cloud or on cloud. So here by default it is 8, totally dependent on your billing cycle. And in our Terraform file, I've defined it as 2. Okay. So similarly, for disk regional, even I did it for IP addresses as well. Okay, so this I'm going to showcase how to go to metrics. Yeah. Okay, it is 500 by default, and we are using 20% of that particular persistent disk storage. And similarly for IP addresses and CPU region, so CPU zonal and regional, you can do anything. But from my point of view, you should at least be doing it for GPUs if you're currently using. So because GPUs cost a lot more, so just do a simple POC on GPUs. In that way, you can really look at if this solution is for you or not. Um, so similarly for CPU override. Okay. So yeah, just paste it, and it is 24 by default. Now we will be running that particular Terraform file, Terraform init, Terraform plan. Okay, so this is the particular thing that like a plan command returns. Okay. Uh, So 10 will be for this particular N2 CPU, and 250 for all other things, the things that we defined in the Terraform file. So now Terraform apply, and in a short while we will be seeing if we would have applied these particular metrics, what impact they might have created. Okay. So just apply Terraform, just type yes, and yeah, it will just take another 10 seconds to get the things applied. Now the main thing is what we did was we were running shell scripts previously. Okay, so before even applying these quotas through Terraform, we were running shell scripts, and as we all know, there is a bottleneck on shell scripts. You can't run for 500 or 600 projects. Okay, so yeah, demo done. And just wait a while. Okay, you just need to reload. Okay, just you need to reload, and it will showcase you the things that you actually configured or changed. You can also undo it in case you want to make 10 to 20. You can obviously do it, but only through Terraform, not through this particular thing. Okay, so let's reload it again. It might take some time to populate. Okay, so there is a flag has override true that you can apply and see which actual metrics have you changed. So here you can see the current particular value is 250 GB and default value was 500 GB. So in this way you can actually change the metrics from the very outside without even notifying Google Cloud. You can always downsize, you can't upsize. Okay, this is a catch. And here, if I try to create a particular disk with more than the specified amount that we have mentioned, 250 gigs, right? So 100 gigs is already consumed. And now if we try to create 200 gigs, it will throw up an error. Okay. So just refresh. Okay. So here the error is task disk failed error, the SSD total GB per project, quota maximum region, US Central 1 has been exceeded. So in this way, if we would have enabled it in the very like while creating our landing zones, while creating our org policies, we might have saved $1 million. So similarly, you can undo it. Okay, you just have to let me do a little bit fast forward. Okay. Okay. Yeah, if so I created another disk of 100 GB, it got created. That was what I was going to show. And you can also change these particular quotas. You just have to select it, and there would be an option to edit those. Now, as we are running short on time, let me go to the keynote again. Okay, so so this was our new layer, okay, new architecture. Entire architecture was same, just one TLB layer was added. I can't tell you the full form of TLB layer because this was named after the client that costed us $1 million. So TLB is short form for that particular client. And our mean time to recovery was 4 months. Only two people are working on this particular project, I and one more person. So it took us 4 months to code everything in Terraform, because previously we were exploring just shell scripts. Then we switched to Terraform because I think we saw some Reddit post regarding that Terraform has this particular thing as well. Still now it is in Google beta thing. Okay, so till now no bottlenecks observed. The only bottleneck is you can only downsize, you can't upsize. Okay, and what happened to the cloud bill? Any doubt? Any guesses? Yeah, so Google Cloud waived that particular bill, so we didn't pay even a single penny. And thanks to Google Cloud for being such awesome and customer support and the things. So some key takeaways. The future thing that we built on this particular tool was that previously we were just running through VM, then we built a platform out of it. So and now we are adding some LLM support to it. So if you pass some thing like I want this particular metric and you don't know the metric name to be downsized to 100, everything in the backend would do the stuff for you. So we are now building a platform on top of it. Set up billing alerts for edge cases. As I showed you, automation can find its way. And as you saw, App Engine costed us more, but unfortunately there is no quota or metric for App Engine. You can't apply to it. So we had to refactor all our code to shift it to some other platform. It is now running in Cloud Run GKE. So if nothing works, refactoring is the only solution for you. And yeah, thank you.